Chapter 3, Lesson 3 of Recalculus, looking at logarithmic functions, and we want to look at the graphs in this lesson. We remember from our discussion earlier that the logarithmic function is the inverse of the exponential function. So if we know what the exponential function looks like, we simply exchange the positive x-axis for the positive y-axis, making that turn and flip, and we will have the graph of the logarithmic function. So let's review very quickly the graph of the exponential function, some of its key parts, and then we'll use that to help us with the logarithmic graph. With the exponential graph, which we have pictured here, you remember this y equals 0 is a horizontal asymptote, and the point 0, 1 or 0a is on the graph. So 0, 1, if we're talking about the exponential a times b to the x, where x is 0, then the y would be 1. So these 2 points are on the graph. So if the inverse of that, or you remember with the inverse then, that the x becomes y and the y becomes x. So instead of this being y equals 0 as an asymptote, x equals 0 is going to be an asymptote, and that's going to be the vertical line x equals 0. And instead of 0, 1 being on the graph, the y becomes x and the x becomes y. 1, 0 is going to be on the graph instead. So if we understand what the exponential function and its graph looks like, it's going to be rather easy to graph the logarithmic because it's simply going to be the inverse. So that kind of gives you the overview. Let's go ahead and take a little bit more detailed look at the graphs of these logarithmic functions then. So our logarithm graphs are going to have this same shape as you see here in the picture. Now these are 2 logarithmic graphs. They just have different bases. You remember the log x is a common log, which is a base 10, and the natural log x is the natural log with a base e, which that number is a little bit more than 2. So you'll notice the difference in the shape based upon a base 10, which is kind of a shallow rise up here above the x-axis, and a base 2, or a little bit more than 2, which is a more rapid climb, although again not a very quick climb, but more rapid than the 10. So from that we should have an idea that a base 10, a base smaller than 10 is going to have a steeper rise, and a base larger than 10 is going to have an even more shallow rise as you come through here. So we'll keep that in mind as we sketch our graphs. A couple of other key things we need to know about the graphs. We have a vertical asymptote, here at x equals 0. Again, that's the inverse of the horizontal asymptote from the exponential. So your vertical asymptote here is x equals 0. And this point, you'll notice both graphs go through that. That is the point 1, 0. Again, if the exponent is 0, then you're going to get a value of 1 as your x. All right. So these would be what the graphs are going to look like. You'll notice they're essentially the same because the bases are the only difference, is between the bases. Once we have the general shape, then our knowledge of transformation is going to apply to both of these. Meaning, if you want to shift it right or left, you're going to have a value subtracted from the x. If you're going to shift it up or down, there's going to be a value added on the outside of this natural log x. A negative sign in front is going to reflect it over the x-axis. A number in front is going to stretch that even further vertically, and then a negative x is going to reflect it over the y-axis. So all those transformations that we've been working with over the last couple of years are going to apply. So in order to graph these, we want to put our asymptote on there. We'll put 1, 0 on the graph. That will always be on the graph. And if you wanted a second point out here, the base as your x value and 1 is going to be another point that you could use. Once you have those points, then you can apply the transformations to both the points and the asymptotes in order to sketch the graphs. All right, so let's look at a few examples, and then and we'll show you how you can sketch these graphs pretty quickly using that knowledge that we just talked about. For our first example, let's sketch the graph of the natural log of x plus 3. So we want to remember the 2 characteristics. We have an asymptote at x equals 0, and the point 1, 0 is on the graph. Now, this x plus 3 in parentheses represents a shift to the left 3, so my asymptote that is normally at x equals 0 has been shifted to the left 3. So my asymptote here is at x equals 3. Now make sure you label those as we go forward. Now we also know that there's a point at 1, 0, but again that point is shifted to the left 3. So I now have a point here, and so again I want to label that point, so that's at negative 2, 0. So make sure you label those 2 points as moving forward. Then we know that the graph rises close to the asymptote, goes through one point, and then has a nice slow rise. It's a natural log and goes up here. Now, I notice this is going to cross the y-axis, so I could figure out what the y-intercept is by putting in 0 for x, okay? So this would be the natural log of 0 plus 3, so the natural log of 3 is f of x. And again, that would be e to what power would be 3. Now I know that e is a little bit more than 2, so I'm going to raise it to a power a little bit more than 1 in order to get 3. So I know that it's going to cross somewhere a little bit above 1 in order to do that. So my graph is going to come through here, it's going to cross here, and it's going to have a nice slow gentle climb. And so this would be the graph of the natural log of x plus 3, and using my shift. Alright, so if we kind of click on that, you'll see I've got a fairly good picture of what the graph looks like. Okay, so again, label the asymptote, the point 1, 0, and then just use your shifts left to right to graph it from there. So let's take a look at another example. We have the natural log of negative x plus 3. And it's always a good idea to take a look at what the transformations are before you actually start doing them. In other words, this negative x means that the graph is going to be reflected over the y-axis. All of the x values are being taken the opposite, so the positive x values are now going to be negative. So a negative sign in front of the x reflects it over the y-axis. This number outside, you remember, is a shift up 3. So let's take the two characteristics of our graph that we know and apply those shifts and reflections. Now, the vertical asymptote, moving up or down isn't going to change it, and reflecting it isn't going to change it, so my vertical asymptote is going to remain at x equals 0. The point 1, 0, there's a reflection over the y-axis, so this is now over at negative 1 as we reflect it over, and then up 3, so, oops, that's not there. Up 3 would be 1, 2, 3, so that point is now over here at negative 1, 3. So the normal x value is reflected, the opposite, and then it's moved up 3. So we know that the graph normally goes up this way if we were to draw a picture. If we reflect that over, that's just going to be folded over, so it's going to start up in my asymptote here, it's going to go through this point and then go out this way. So sorry I missed that. And so this would be the graph of this function with those two transformations. And if we graph that, you can see that's pretty much what we have. Okay, so again, remember the asymptote and the point 1, 0 are your 2 points of characteristics that you want to look at, and then you simply apply the transformations to those two key parts of the graph that we're looking at. I'm going to do 4 more examples. You can watch as many as you need. Some will be natural log, some will be log, but they'll all be the same in that you simply take those 2 characteristics that you know and use the transformations to sketch the graph of the new function. In this example, we have the natural log of 5 minus x. And in a case like this, when I have a shift right or left going on inside and a reflection, I think it's easier to take the reflection and put it in front, or in essence factor out the negative sign, and then it's easier to make the shift and do the reflection from there. So in this case, I'm going to put the negative sign out front, so I still have negative x, and that makes this a negative 5, and because this negative times negative makes this positive. And in this way, I can see what the shifts are and the reflection a little bit easier. So now I see that I have a reflection across the y-axis, and then I also have a shift to the right 5, excuse me. So my vertical asymptote is shifted to the right 5, 1, 2, 3, 4, 5. And so I have this asymptote at x equals 5. And then I have the point 1, 0 that would be right here, okay, just moving 1 to the right of the asymptote. However, I have a reflection over this, so it's going to reflect over this asymptote, so the point is now going to be right here, so this is going to be the point at 4, 0. And again, the reflection makes the graph, instead of going this way, it's like folding it over that line, so the graph is going to come up through here and then go up this way. So this would be the graph of the natural log, and with this reflection and its transformation. And I think if we click on this, we'll be able to see that I'm pretty close to what it should be. Okay? So when you have a negative sign or a reflection going on, it's best to put that reflection outside so you can see what the shift is, and then you can make your graphs. Again, I'm going to do 3 more examples. You can watch as many as you need. That will help you with those sketching these graphs on your own. For this example, we have a -1 plus log of x. Now again, we're not used to having this number out in front as far as seeing the reflections or transformations, but if I put it like this, then we can see it a little bit easier. So there is no transformation right or left. There's simply a shift down 1. So we're going to take our 2 parts, our vertical asymptote, which is at x equals 0. The shift up or down is not going to affect that at all, so that's going to remain at x equals 0. And then this point 1, 0 is going to be shifted down 1. So this point is now going to be at 1, -1. And that's all there is to this transformation. So my graph is going to come like this. And whoops, that's probably not quite right. It's going to, it's log base 10, so the climb is going to be kind of more shallow than the natural log, so it's going to look something like that. So if we click on this, I think we get a good picture of what it should be, and you'll see we're fairly close. All right, so go ahead and do 2 more examples. Again, you can keep watching if you need. If not, if you think you have it, then go ahead and tackle your homework. Okay, for this example, we have a couple things going on. The negative sign in front is a reflection over y, so it's going to turn it upside down. The negative sign in here is going to reflect, I think I said y. That's going to reflect it over x. The negative sign here is going to reflect it over y. And then this 2 is going to be a vertical stretch, so it's going to stretch that out vertically, so it's going to climb a little bit quicker than it would normally. So understanding what those transformations are, let's go ahead and do those transformations to our 2 parts. So the x equals 0 asymptote, there is no shift right or left, so that's not going to be affected in any way, so that's going to remain at x equals 0. Now the point 1, 0, there's a reflection over the x-axis, which isn't going to change it, but there's also a reflection over y, so that's going to be over here. So now this is the point -1, 0. Now the 2 is a vertical stretch, so what you'll do with that 2 is you'll multiply it by the y value. Well, the y value here is 0, so I'm still going to have the point here is going to be at -1, 0. And again, it's reflected over x because of this, so it's going to go upside down, it's going to go through that point, and the vertical stretch is going to make it stretch out or climb a little bit quicker than it might normally based upon a base 10 graph. So if we click that, you can see I've got a pretty good picture of what that is. All right, one more example for you, and then you can tackle your homework. In our final example here, we have a lot going on, so let's take a look at what we have going on and then we'll graph it. So again, because we have a negative sign in front of here and a transformation, we're going to put the negative sign out in front so that we can see what that transformation is, and then we'll go ahead and apply those. Okay, so the negative sign in front is a reflection over x, so the graph that normally goes like this is now going to be going down. The negative sign in front reflects it over the y-axis, so it's going to be going down this way. This is a shift to the right 1, and then this is a shift up 1. So let's take those transformations and apply them to our 2 parts. So the first part is the x equals 0 asymptote, and the only thing that's going to affect that is this horizontal shift to the right 1. So my asymptote is going to be at x equals 1 now with that shift. So we'll go ahead and label that. So now we have the point 1, 1, which is normally here. And again, this has a horizontal shift to the right 1, and it has a vertical shift up 1. And then we have a reflection over the x-axis, the y-axis, because of that negative sign in front of the x. So we're reflected over here, so we're 1 away this way, so we're going to be right here. And then we have a reflection over the y, which is going to turn the graph, reflection over x, which turns the graph upside down. And then we have this vertical stretch of 3, which means we're going to multiply the y value by 3. Well, this point is at 1, 0. The y value is 0. When we multiply it by 3, it's still 0, so the point at 1, 0 doesn't change. So applying all those graphs and reflections, we have this that goes through like this. So we have a graph that looks like this after we apply those transformations. And you can see that we're pretty much the same. Okay, so that's how you want to describe the graph and look at those transformations. X equals 0, 1, 0, those are the two parts. Then just apply your transformations to those and you'll be in good shape from there on.